Welcome back to the deep dive. Today, we're really cutting through the hype to look at something potentially groundbreaking in AI. Anyone who's, building in the space or even just watching closely knows about this problem. The sources we looked at call it the impossible triangle.
Right, the impossible triangle. It's
Yeah.
that constant headache, isn't it? You want amazing performance, right?
Yeah.
But push for that, and suddenly your costs go through the roof and everything slows down.
Exactly. Or you aim for super fast, super cheap.
And you end up with something kind of dumb.
Yeah.
Historically, you've always had to sacrifice one side, pick two. That's the rule.
But what if that rule is changing? That's what we're diving into today. There's this new development from a major player overseas. They've just launched a new model, Miniax M2, and this agent product that goes with it.
Mhm.
And the claim is bold. They say they've basically found a cheat code for that triangle.
Yeah, and our mission here is to really unpack that. How are they supposedly doing this? Delivering, as they put it, intelligence for everyone.
Hmm.
Because this isn't just another model update. The sources we've read suggest it's a bigger shift, moving beyond just, chatting with an AI,
Towards what exactly?
towards AI agents that can independently tackle complex tasks. Some researchers are even calling this agent tech an excellent vehicle for exploring AGI. It's a pretty big claim.
Okay, let's ground this. The first thing that jumps out, and frankly, it sounds almost too good to be true, is the cost. They're saying this M2 model's API pricing is just 8% of a major competitor. We're talking models like Claude Sonnet as the benchmark here.
8%. So bam, there goes the cost side of the triangle, potentially. And then there's speed. They're claiming nearly double the entrance speed compared to that same expensive competitor.
Double the speed, 8% of the cost.
If that holds up,
Well,
well, you can see how that can seriously shake things up.
Yeah.
It changes who can afford to build cutting-edge AI.
Okay, let's unpack this. I'm naturally skeptical. How do you slash costs by 92% and double speed without gutting the quality? They must have designed M2 specifically for this, right? From the ground up.
That's exactly it. The sources are clear. M2 was, and I quote, born for agents and code.
Yeah.
The internal goal was super specific. They needed a model that could handle those really complex, long-chain tasks agents do, calling different tools, planning steps.
Mm-hmm.
But, and this is key, it had to be cheap enough for their own thousands of engineers to use constantly, every single day. If it cost too much internally, nobody would adopt it.
Ah, okay. So internal necessity drove the external pricing strategy. Let's talk numbers then. What are the actual API costs?
Right, the details matter. Input is priced at 0.3 cents per million tokens. Output is 1.2 million tokens.
Mm-hmm.
And when you actually run those numbers against the big overseas players, yeah, that 8% figure holds up. It's dramatically cheaper.
And the speed, the TPS.
Tokens per second, yeah. They're hitting around 100 TPS in production, which, again, compared to the high-end models from competitors, is consistently about double.
Double the speed, 8% cost. The math still feels off. There has to be an architectural trick here. The sources mention something about the model size versus how much is actually used.
Bingo. This is the core insight, I think.
Yeah.
The model itself isn't small, right? It's got 230 billion parameters, which puts it in the large model category capable of high performance. But they use mixture of experts technology.
MOE.
MOE, right, where it only activates parts of the network.
Exactly. Think of it like having a big team of specialists. When a query comes in, a gating mechanism routes it only to the relevant expert subnetworks. So even though the whole model has 230 billion parameters for any single input, only about 10 billion parameters actually fire up and do the work.
And the cost implication of that is?
Huge. You're only paying the compute cost for those 10 billion active parameters, not the full 230 billion. That's the trick. That's how they balance performance with speed and cost. Sparse activation. It's a really clever way to make powerful AI affordable. Okay, that makes sense. It reframes size, doesn't it? Size gives potential, but efficiency delivers it. And given that efficiency, M2 seems built to be a great tool user, especially for coding. The sources highlighted its outstanding planning and stable execution when juggling tools like the shell, a browser, Python.
Yeah, and that leads directly into the agent product they built using M2. The company's even reorganizing internally around this idea. They call it becoming an AI-native organization, which basically means they're using these M2-powered agents to automate some seriously complex internal stuff.
Like what kind of stuff? Are we talking chatbots here or more?
Oh, way more. Think processing huge amounts of customer feedback to find the real issues, or doing initial screening of developer job applications. And a big one is daily coding tasks, interacting with APIs, running tests. It's about automating high-level, repeatable cognitive work.
Interesting. And for external users, they've packaged this agent into two modes.
Correct. First, there's lightning mode. Think of this as the fast, efficient option for simpler things. Quick Q&A, summarizing a short text, maybe a bit of light web searching. It's designed for instant output, enhancing existing chat experiences.
Got it. And the second one?
That's Pro mode. This is where the heavy lifting happens. It's for the complex, maybe long-running tasks. We're talking in-depth research reports, developing software, creating detailed presentations or documents. This mode uses the full agentic capabilities.
And the workflow in Pro mode sounds quite different, more transparent.
Very much so. Based on the testing reports, it doesn't just start generating. First, it visibly pauses like it's thinking. Then it actually shows you a to-do list on screen. Here are the steps I'm going to take. And then it executes them one by one, often using a kind of virtual window or browser, ticking items off the list as it completes them.
That visibility is huge for trust, isn't it? You see the process, not just the result. Okay, let's talk results. How did it actually perform in testing? Deep research, for instance.
This was one of the standout examples. The agent was asked to create a complex report in Arabic on a pretty niche subject. It managed to pull information from 25 different sources. And crucially, many of those original sources weren't even in Arabic. They were English or other languages. So strong cross-lingual synthesis there.
Impressive. And the output quality.
The formatting in the final PDF or document was apparently excellent, really professional looking. But, and this is important for impartiality, there was a trade-off: speed. In Pro mode, for these deep tasks, it was noticeably slow. Slower than competitors.
Slower. Okay. Any other drawbacks on the research side?
Yeah, a significant one for serious work. No inline citations. It gave the list of 25 sources at the end, which is good. But you couldn't easily trace a specific claim back to its source within the report.
Right.
That limits its use for academic work or anything requiring rigorous fact-checking.
Right, that's a key detail. What about coding? You said M2 was born for code. Did it live up to that?
It really seemed to. One test involved building a fairly complex annotation tool, a non-trivial task with multiple parts. The agent apparently nailed 95% of the required functionality on its very first try. Think about the time that saves a developer.
95% first time. Wow. And there was something about self-correction. That sounds very agentic.
Yes, this was fascinating. The sources describe the agent having its own internal checking or testing sub-agent. So after generating the code, this internal checker reviewed it, actually found a bug, and fixed it automatically. No human needed to intervene for that step.
An agent debugging its own code.
Exactly. It's like having a built-in QA step. That's a level of sophistication you don't often see in commercially available agents yet. Really interesting.
Okay, one more area. Presentations. Generating PowerPoints or slides. Often a weak spot for LLMs.
Here, it seemed to do surprisingly well on the design front. When asked for a detailed presentation, it didn't just spit out boring bullet points. The output was described as having a complex professional design aesthetic.
And the interaction was different too. It didn't just generate, it asked questions.
Right. It apparently proposed design options first, like, would you prefer a Swiss design style? And it waited for the user to confirm before actually building the slides. That makes it feel much more collaborative, less like just pushing a button.
But like the research function, there were some technical snags. File issues.
Yeah, this seems like a wrinkle they need to iron out. The downloaded PowerPoint file itself was often corrupted or broken, which is obviously a problem. However, the presentation was reportedly fully editable within their web platform, kind of like using Google Slides, so you could tweak it there. And the PDF export of the presentation was always perfect. So workarounds exist, but the direct PPT download needs fixing.
Any outright failures noted?
One specific one mentioned was with multimodal generation involving non-English text. It failed when asked to put Arabic text inside generated images or infographics for the presentation. It could handle the Arabic text fine on its own, but integrating it into visuals was a problem.
Okay, so pulling this all together, we have incredible cost efficiency, great speed, strong coding, decent research with caveats, creative presentation design with file issues. How does it actually rank? What do the benchmarks say?
Well, focusing on the core agentic skills tool use, planning. Deep Search M2 performs very strongly. The results put it right up there, very close to the top international models on those specific metrics. And on one comprehensive benchmark, artificial analysis, which combines results from 10 different tests, it ranked in the top 5 globally overall. So the capability is definitely there. It's professional grade.
And crucially, people can try this now. How accessible is it?
Extremely accessible, at least for a limited time. The company's offering free access to both the agent product and the M2 API. That free trial runs until November 7th. It's a huge window for developers or anyone curious to experiment with these advanced agent capabilities without any cost.
Free access is great. What about running it yourself locally?
They've done that too. The full M2 model weights have been open sourced on HuggingFace, which means, yes, you can download it, run it on your own machines. And it's supported by popular tools like VLLM and SGLang that help optimize running these big models locally.
So the barrier to entry for this level of performance just plummeted.
Absolutely. That combination, the 8% cost, the double speed, the MOE efficiency, the open source option, the free trial.
What does it mean for, the listener, the developer, the researcher, or maybe a small business?
I think it means that cost is potentially no longer the biggest hurdle to using sophisticated AI agents for complex work. Tasks that might have been too expensive or too slow before, deep analysis, coding assistance, complex automation, suddenly become much more feasible. It really leans into that intelligence for everyone idea. It could democratize access to these capabilities.
That's really the heart of it, isn't it? This whole effort with Minimax M2 and the agent seems laser focused on cracking that impossible triangle, bringing these advanced agent skills, especially coding and research, down to a price point and accessibility level we haven't seen before, thanks to that clever MoE architecture.
Yeah. And maybe a final thought for you listening is about what this implies for the future.
Mm.
We have a model here that's, well, maybe not the absolute biggest in terms of total parameters, but it's using them incredibly efficiently, only 10 billion active per query. And it's achieving results near the top of the global benchmarks.
Mhm.
Does this signal a shift? Is raw size becoming less critical than smart architecture, efficient tool use, and that sparse activation? Something to think about regarding where the field is heading.
Absolutely. And we'd love to hear your thoughts on this too. If you've had a chance to try M2, either the API, the agent, or the open source weights, how does it compare to other agents you've used? Does the performance, especially maybe the slowness in pro mode, justify the cost savings? What's your take? Let us know in the comments. We do read them.
We really appreciate you joining us for this deep dive. If you found this breakdown useful, maybe give it a like, consider subscribing if you haven't already, and hitting that notification bell helps too. And please do share this with anyone else you think might find this analysis valuable. We'll catch you on the next one.